Hello everyone, in this video we will understand the banker's algorithm. First of all, we will see why and where this is used. So basically this is used in deadlock avoidance. So what do you mean by deadlock avoidance? This means to avoid the deadlock, that is a deadlock point should never reached. So how this can be achieved? For this we will require some future information, or we can say prior information. So what kind of prior information is required? Information about the processes, the information about the resources. What kind of process information is required? Number one, the number of processes, then each process having the resource, then the information about the each process that wants the resource, and lastly its maximum requirement for the resource. Next, what kind of resource information is required? Number one, again the number of resources. Now here please keep this in mind that there are many resource types. For example, 5 printers, 3 scanners, 8 answer sheets and so on. So total number of resources of each type or instances we can see. Next is resource allocated to each process, and last information we require is the available resources. Okay, the banker's algorithm is similar to the algorithm which is used in the bank. So as to provide money to each and every customer of the related bank. So now we will see three different examples that are solved using the banker's algorithm. So now I am starting with the first example. So here you can see the snapshot of a system. On the left hand side you can see there are 5 processes. It starts from the P0 to P4. Okay. Then in the next column you can see the allocation. This means the allocation of the resources type A, B, C, D are allocated to the each and every process. Next is the maximum requirement of the resources which is required by each and every process, and last the actual available resources. Now what is our question? We need to find the need matrix, and also we need to find is the system is in a safe state or not, and this we need to solve using the banker's algorithm. So now what is our first question? We need to find the need matrix. So how we will find this? The simple formula for calculating the need matrix is the maximum requirement minus allocation. Maximum requirement minus allocation. Allocation is nothing but the resources which are allocated to each and every process, and the maximum requirement is nothing but the requirement of the resources by each and every process. Okay, so in the fourth column you can see the remaining need of each and every process according to its resource type. So by using the formula maximum requirement minus allocation, you can see the answer we will get as 0, 0, 0 and 0. How? So 0 minus 0 we will get the answer as 0, 0 minus 0 again the answer as 0, 1 minus 1 the answer as 0, and last 2 minus 2 the answer we will get as 0. Now we will consider for P1. 1 minus 1 we will get the answer as 0, then 7 minus 0 we will get the answer as 7, then 5 minus 0 5, and 0 minus 0 0. Similarly we can evaluate this for P2, P3 and P4. So now I am proceeding. Our next question is to find out the safe state. So what can be the formula for the safe state? First of all, need should smaller than equals to the available resource. Need of each and every process must be smaller than equals to the available resource. So with us we are having the available resource as 1, 5, 2, 0. Okay, so now we will solve this in sequence. So first of all we will consider the P0. Okay, the process 0. So what is our formula? Need is smaller than equals to available resource. So what is the need of P0? 0, 0, 0, 0. Is it smaller than equals to the available resource, that is 1, 5, 2, 0? Yes, the condition is true. Thus P0 will get executed. Now we need to update the value, right? So that we will get the new availability, that is nothing but the new available resource. So new availability will be equals to the availability plus allocation, that is nothing but the current availability plus the allocation of P0. So we will get the answer as 1, 5, 3 and 2. 1, 5, 3 and 2. So this is our new availability. So now I am proceeding with the P1, that is the process 1. Again we will use the same formula. Need is smaller than equals to the available resource. So what is the need of P1? 0, 7, 5, 0. Is it smaller than equals to the available resource? You can see here the updated resource, available resource is 1, 5, 3, 2, right? So we need to use this particular value and not the initial value. Okay, we find that the condition is false, right? We find that the condition is false. So P1 is not executed. So now we will proceed with the process P2. Again we will check for the condition. Is it getting true? Yes, the condition is getting true. We will execute the P2 and we will update the value of the available resource. So we will get the new available resource as 2, 8, 8, 6. Then we will proceed with the process P3. Again we will go and check for the condition. Whether the condition is true? Yes, the condition is true. And then we will update the available resource value. So we will get the answer as 2, 14, 11, 8. And our last process is P4. So again we will check the condition. Yes, we find that the condition is true. So we will execute the P4 and we will update the value. The updated value will be 2, 14, 12, 12. But remember, our one process is still remaining and that process is P1. So now we will check the condition for P1. Again we will use the same formula. Need is smaller than equals to available resource. Yes, the condition is true for P1. Now we will execute the P1. Okay, after that we need to update the value. So our updated value will be 3, 14, 12, 12. Okay, so this is our final available resource. Okay, so now what is our question? We need to find out the save sequence. So first of all we have executed P0, then P1 we have not executed, then P2, then P3, then P4, and at the last P1 has been executed. So this is our save sequence. So in this way we need to solve the bank example using the banker's algorithm. So now I am proceeding with the example 2. Again you can see the snapshot of a particular system. So here you can see there are 3 instances of the resource as A, B and C. Again we need to find the content of the need matrix. Next, is the system is in a safe state, and lastly, if a request from the process P1 arrives for 1, 0, 2, can the request be granted immediately? Let's see. Again we will use the same formula for need matrix. We will evaluate the need matrix as maximum requirement minus allocation. We will get the answer as 7, 4, 3 for P0, 1, 2, 2 for P1, 6, 0, 0 for P2, 0, 1, 1 for P3 and 4, 3, 1 for P4. We will do simple subtraction here. Then our question is the system is in a safe state? Again we will use the same formula. Need is smaller than equals to the available resource. Again we will start from P0 and we will check the condition. Yes, the condition is false here, so we will not execute the P0. So the available resource will be 3, 3, 2 only. We will not update the value. Next we will proceed with P1, the process 1. Again we will check the condition. Yes, we find that the condition is true. So we will execute the P1 and we will update the value as 5, 3, 2. Then we will proceed with P2. We will find that the condition is false. We will not update the value as P2 is not executed, but our current available resource is 5, 3, 2 only. Then we will proceed with the process 3. So again we will check the condition. We find that the condition is true. So we will execute P3 and we will update the value and our new availability will become 7, 4, 3. Then we will check for the process 4, that is P4. Again we find that the condition is true. We will execute P4 and we will update the value. Our new availability will become 7, 4, 5. But remember, there are two processes which are still not get executed yet, that are P0 and P2. Now we will check for P0. Again we will check the condition. Yes, we find that the condition is true, so we will execute P0. Okay, so now we will update the value of available resource. We find that we got the value as 7, 5, 5. And lastly we need to check for P2. We find that the condition is true. We will execute P2 and we will update the value. So we will get the final available resource as 10, 5, 7. So here we need to find out the safe sequence, right? So in what sequence we have executed our processes? First we have executed P1, not P0, then not P2, then we have executed P3, then P4, then at last we have executed P0 and P2. So this is our safe sequence. So what is our third question? In this particular question, if a request from a process P1 arrives for 1, 0, 2, can the request be granted immediately? Let's find it out. So what is our request for P1? It is 1, 0, 2, right? So we need to find this two criterias. These two criterias must get satisfied. So what is our criteria 1? Request should be smaller than equals to the need. Request should be smaller than equals to need. And our criteria 2 is request must be smaller than equal to the availability. Request should be smaller than equal to availability. Now we will see whether the condition is true or false for the criteria 1 and criteria 2. Yes, we find that the condition is true for both the criteria. Now we need to update the value for the particular process, that is P1. So we will get the new available resource. We will get the new available resource as current availability minus request. So here you can see at the initial state, what is the value of the available resources? It is 3, 3, 2, and we are not using 10, 5, 7. Okay, so we will use 3, 3, 2. So we will minus this with the request. We will get the particular answer as 2, 3, 0. So our new available resource will be 2, 3, 0 and not 3, 3, 2. Now we will update the value for the allocation of the particular process P1. So what is the formula for it? The allocation, that is the current allocation plus request. We will get the answer as 3, 0, 2. And finally we will update the need of the process P1 and we will get the answer as 0, 2, 0. Now here we need to solve the particular example from the start, from P0, okay, from P0 and not P1. So here, after solving this, using the particular availability as 2 comma 3 comma 0 and not 3 comma 3 comma 2, okay, we need to consider the available resource as 2 comma 3 comma 0 only, and then we will solve the particular example starts from the P0. We will find that P0 will not get executed as it will not satisfy the condition need is smaller than equals to the available resource. Okay, after that we will consider P1. Yes, we find that the P1 will get executed. So we can say if P1 is executed, then the request is granted immediately. So what was our question here? So this was our question. If a request from process P1 arrives for the request 1 comma 0 comma 2 can be granted immediately. So the answer is yes, the P1 will get executed immediately, okay, for the request 1 comma 0 comma 2. So now I am proceeding with the next example. Again you can see the snapshot of a particular system which is having the 5 processes and some resources instance. But here you can see the difference between this example, that here the available resource is not given as like the question number 1 and question number 2. Now in this kind of question we need to evaluate the available resource, we need to evaluate the availability, okay. But yes, in the question it is given for the instances we are having the value 7 for A, 3 for B and 6 for C. Again we need to find out the need matrix and we need to find out the is the system is in a safe state or not. So we will find out the need matrix using the particular formula. Before that we need to find out the available resource. So from where this value has came, 3 comma 0 comma 1, where this value has came. So for this we will require the addition of the allocation of each and every instances of resources. So on the second column you can see for A we are adding 2 plus 1 plus 1. So we are getting the total allocation for A as 4, the total allocation for B as 3, the total allocation for C as 5. Now why this is required? So this is required for getting the answer for the available resources, or we can say it as the availability. So the formula for the availability is the total resource instances minus the allocation, that is nothing but the total allocation. So in our question what it is specified, we are having the total resource instances as 7 comma 3 comma 6. So we need to evaluate this, right. So we will require this particular value for getting the answer for the availability. So 7 comma 3 comma 6 minus the total allocation, whatever answer we got here, okay. So by evaluating this we will get the answer as 3 comma 0 comma 1. So for example in exam you may ask that how many resource types are present. So you can use the simple formula as total resource instances will be equals to available resources plus allocation. Then after this you need to consider this particular value 3 comma 0 comma 1 as the new availability, and you need to solve this particular example starts from the P0 till P4, so that you will get the safe sequence. So in this way you need to solve the 3 examples which are of different kinds. Thank you.